All right, welcome to day 2 of predicting products for chemical reactions. So we did synthesis reactions, so now today we're going to focus on decomposition reactions. Now, if you looked at the notes, or maybe you just know what the word decompose means, essentially we're looking at one thing breaking down into two things. So if I use AB to represent a compound, it's going to break up into two smaller pieces. So whether it's an element in an element, or an element in a compound, or maybe if it's a compound breaking down into two compounds. So essentially, we're just going to make the assumption that any decomposition question that I'm going to give you just breaks down. Now, there's a lot of different rules that go along with decomposition reactions. And if you look to this lovely assignment that you have, it actually gives you specific rules for different things like carbonates, sulfates, hydroxides, chlorates, etc. So I'm going to do a few examples of those for you right now, and we're going to balance them, and then I'm going to let you do these 8 questions on your own. So maybe we'll start with a basic binary compound. So if we remember, binary just means 2 elements. So I'm going to do NaCl. So if we're going to break down sodium chloride, because it's just a binary compound, it just breaks down into the 2 elements that come together to make it. So once again, we got to remember, chlorine is a diatomic element, so it breaks down and makes sodium and Cl2. So top corner, I'll just do it again. We have our hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine are my diatomics. So make sure we always have those when they're by themselves with the 2. So last step is going to be to balance this. So if I have sodium chloride, I have 1 Na and I have 1 Na. I have 1 Cl, whereas I have 2 Cls over here. So I'm going to put a 2 in front of my sodium chloride to balance my chlorines. And now this 2 is distributed to both elements. So I have 2 sodiums, and I'm going to put a 2 in front of this Na. And now my reaction is totally balanced. Now, when we're dealing with a binary compound, obviously we can see it's a lot easier just to see the simple breakdown. But if we have something slightly more complicated, like maybe we're dealing with a carbonate or a sulfate. So let's do magnesium sulfate. So I have Mg, which is a +2, and SO4, which is a -2, so they combine just to make MgSO4. Now, when these compounds break down, they make sulfur trioxide. So we have SO3, and then an oxide compound. So basically, we got to remember, we're going to take this compound right here, and this is kind of where it's breaking down. So Mg makes a +2. Oxygen is a -2. So when those 2 things come together, they're going to make an MgO. Now, luckily for us, this one kind of worked out very nicely, where we can see we have 1 Mg, 1 Mg, 1 S, 1 S, and then we have 4 oxygens. And this one can sometimes get more tricky because we can have an O3 and then an O over here, so they're in 2 separate compounds. But for this one, it works out that on this entire side, I have 3 oxygens plus 1 more, and my compound is balanced without adding any coefficients. So now, what would happen if we did a chlorate? So intentionally, I'm going to try to make this one a little bit more complicated. If I did like aluminum chlorate, so aluminum's a +3, chlorate, which is ClO3, is a -1. So aluminum chlorate is breaking down. So when this breaks down, it makes oxygen, which oxygen is one of our lovely diatomic elements, so it's going to be O2 plus, and then a chloride compound. So it's going to be our Al +3 with our Cl -1. So it's going to make AlCl3. So we can see it's just this compound broken down into 2 pieces. Now we got to figure out how to balance this. So I have 1 Al and 1 Al, so that's not a problem. I have 3 chlorines, and I have 3 chlorines. Cool. Now I have 9 oxygens because this 3 goes to both, and only 2 oxygens over here. So the way I like to start these is automatically, if you put a 2 in front of this, it's usually going to make your life a lot easier. If it doesn't work, we can go back and try something else, but for right now, I'm just going to put a 2 here. So right off the bat, I now have 2 aluminum, so I'm going to put a 2 in front of this. Okay. And now I have 3 chlorines times 2, that's 6 total, and 2 times 3 is 6. Okay. Now I have 3 oxygens times 3, that's 9. Twice, which would be 18. So then to get O2 to 18, I would have to put a 9 in front. Now, when we look at these, we always want to make sure that we can't reduce our coefficients. If we can, that means we did something else wrong along the way. So here I just have 2, 9, and 2. We can't reduce them, so that would be my final answer. So I want you to go in and try these 8 questions. And once again, if you want to email me a picture of your work on a separate sheet of paper, if you have any questions on any of these, please feel free to let me know.